Hello and thanks for watching. Today on this video we're going to discuss where this slope-intercept form come from. We're going to explore through a couple different formulas that you commonly see in algebra and show where does slope-intercept form derive from. So the first thing we're going to look at is actually slope. We're just going to talk about where does slope come from in relation to the rate of change. Slope is just a change of y over the change in x. So if we look on the graph and we pick any 2 points, we can find the change of y, or in this case it's 3, and divide it by the change in the x, which in this case is also 3. That's where the formula m equals y2 minus y1, or the change in the y, over x2 minus x1, or the change in the x, comes from. Now using that formula, we're actually able to find the point slope form. So in this situation, we can think of two ordered pairs, xy and x1, y1. We can substitute them in that formula for rate of change or slope, and we end up with m equals y minus y1 over x minus x1. If we multiply both sides by x minus x1, it simplifies to m times the quantity of x minus x1 equals y minus y1. And if we use the symmetric property to rewrite, we end up with point slope form. Now using point slope form, we can actually find where slope-intercept form comes from. By choosing the ordered pair for slope-intercept form, we want to find where that point that crosses through the y-axis is. We know the x value would have to be 0 since it's crossing through the y-axis, and we're going to create the y value as b. If we substitute in to the point slope form for y1 and x1, we end up with y minus b equals m times the quantity of x minus 0. If we simplify x minus 0 to x and solve by adding b to both sides, we end up with the formula y equals mx plus b, which is, in fact, the slope-intercept form. It's actually pretty interesting how all of these formulas look very similar and how they're all interconnected. I hope you enjoyed watching, and I hope it made you make some sense out of the math. Have a great day!